Hello everyone. In this third video we're going to just do one example from the homework and then another application example, and you'll see some similar ones to that in the homework. But this one is evaluating the following expressions. Alright, and this is the second problem on the homework, but one thing I want to point out, right, it's saying give an exact answer in radians. Alright, so how do we do that? How do we get the answer in radians? We can use our calculator to help us. I'm going to do it by hand first for this first one, and then I can show with the Desmos calculator. You can use your phone calculator or your handheld calculator after that. You should know how to do it on a handheld calculator for sure. Alright, so this problem, remember, we've got inverse cosine of, oops, jumped up on me a little bit there. Okay. Try this again. Square root of 3 over 2. Sorry about that. Alright, and well, what is that going to equal? Remember, the inverse trig functions give us angles, so I like to use descriptive Greek letters for those angles. Now, this is equivalent to saying, well, if the inverse cosine takes the number square root 3 over 2 to the angle theta, then the original function cosine must take the angle theta to the square root 3 over 2. Alright, and the inverse cosine is going to give us an angle back in quadrant 1 or 2, so we would either have to go over to the unit circle picture, which is fine to do that, and look for what angle has a value of square root 3 over 2. Alright, so let's do that quick, and then we'll check it with the calculator. Alright, so going back to our unit circle picture, remember x is equal to cosine, so we would want to be saying to ourselves here, what x coordinate is the square root 3 over 2, and we're seeing that that's equal to pi over 6, or 30 degrees. Okay, so for this one, we can see by looking at the value and knowing our 30, 60, 90 triangle that theta is equal to 30 degrees or pi over 6 radians. Alright, so the answer for this one's going to be pi over 6. Alright, again, we will check that with the calculator in just a minute. Let's do this next example. Again, how would we do inverse cosine of negative square root 3 over 2? Okay, well, again, same thing, call that theta, rewrite that into kind of a more familiar situation. Cosine of what angle would give us negative square root 3 over 2? Alright, now for that one, let's go back to the picture, and then we'll start using the calculator after it. Going back to the unit circle, remember x is the x coordinate of where your terminal side hits the unit circle is cosine. We would want to be looking for in the second quadrant now, because we want a negative x coordinate where we get square root 3 over 2, and that's 150 degrees or 5 pi over 6 radians. Okay, so looking at this equation, then looking at the unit circle, we would say, okay, theta is 150 degrees, which we now know we can convert that to 5 over 6 radians. Alright, we'll come back and do inverse sine of 1/2 in a minute, but let's just double check this one on the calculator. So we have to input this in radians, so we're going to have to type in 5 pi over 6 for this problem. Now, a good way to do these ones, looking back at the unit circle is excellent. It just reinforces the angles for us in the 30, 60, 90 triangle. Let's see how to do this in Desmos. Alright, okay, so once again, we want to go ahead and type in the inverse trig function. So we're going to open up the keyboard, find inverse cosine. Let's do both of them. So we're going to do square root of 3, get outside of the square root, divided by 2, close it off. Now, I do have this already in degree mode. Remember, if you hit the wrench here, you can flip between degrees and radians. Radians is more difficult to work with. That is equal to pi over 6, but it's not going to tell us that. So I think it's simpler to say, okay, get it in degrees first, it's 30 degrees, then convert that over to radians using the unit circle picture. That's pi over 6. Okay, likewise for inverse cosine of negative square root of 3, and then after that divided by 2, it's telling me 150 degrees, so we know that that is equal to 5 pi over 6, converting that over to radians. Alright, going back to the last example here, let's do this one on the calculator exclusively. Inverse sine of negative 1/2. Okay, so going back into Desmos, we're going to go to the functions. Now we're going to do inverse sine, and we wanted negative 1 over 2. It's telling me negative 30 degrees. Okay, now this one, we got to think about it a little bit. Negative 30 degrees. What is that equal to? That's going to be negative pi over 6. Okay, so let's write that one out a little bit. So our calculator is telling us that the inverse sine, or arc sine, of negative 1/2 is going to give you negative 30 degrees. Now, you can't type in negative 30 to this, so you'd have to convert that over. If you want, don't worry about the negative sign. Let's just go back to our picture. 30 degrees is equal to pi over 6, so therefore negative 30 degrees is going to equal negative pi over 6. Just negate both, which this is then going to give me negative pi over 6. All right, so our answer in here, we'll go back to type it in. It's going to be negative pi divided by 6. Okay, so some of the problems are going to ask us to do it in radians. We got to be comfortable doing that. I would suggest, if you're going to use your calculator, convert it over in degree mode. Then after you have it in degrees, convert it to radians if it's a familiar angle. All right, let's do one more example here to finish off. This is an application problem. In this one, notice we're given a situation and we can see a right angle triangle in the picture, but we're not given the angle. We need to find the angle. So the problem says we have a tower that's 125 feet tall. It casts a shadow 172 feet away from the tower. Find the angle of elevation. So this one's looking for the angle of the sun to the nearest degree, because the sun is going to create that shadow. All right, now looking at the right angle triangle we've got in the picture, if we're looking at this angle, then we have the opposite side and the adjacent side of that right angle triangle. And what trig function connects together the opposite and the adjacent? That's the tangent function. Tangent is equal to opposite over adjacent in the right triangle trig definition. All right, now we're going to plug our numbers in. All right, so now we're going to write down, okay, tangent of theta, we don't know what that is going to equal, well, the opposite side is length 125, the adjacent side is length 172. All right, so now this example, notice, is kind of the reverse of some of the previous ones that we've done, where we were starting out with the inverse trig function and then converting it back to tangent. This one, we're starting with the tangent, and now we want to go and do the opposite of tangent, which is arctangent. So we need to write down that equivalence. Let's do that now. So what is this equivalent to then? This is going to apply or be equivalent to saying theta is then going to equal the inverse tangent of 125 divided by 172. Okay, and that's what we need to then plug into our calculator. So this is going to be an acute angle. We'll go plug it in the calculator. It's telling us to the nearest degree. We'll just plug it in and get a decent answer here, or decent decimal result. All right, so again, let's go back to Desmos. Let's compute. Now again, we're going to go to functions, inverse tangent, and we're going to do 125 divided by 172. Close the parentheses out, and we're seeing 36.62. So I can. It's not letting me do that during the video recording. That's okay. I'll copy and paste that in after, but it's 36.0076. All right, so let's just jot that down in the notes. All right, using a calculator, we're seeing that theta is approximately 36.0076 degrees. If we want that in radian mode, we can certainly get it in radian mode, but most of the problems dealing with applications are going to ask us to give it in terms of degrees. Okay, so again, this is a recap here. Let's just kind of overview these last two examples. The application one, we wrote down from the right angle triangle that tangent of the angle we're looking for was equal to 125 over 172, and then we took the inverse tangent to help us find that angle theta. So that one, we started out from the tangent point of view and we used the inverse after that. The previous one, we were given inverse trig functions and trying to evaluate with those. We can convert them if we want to approach this by hand from an inverse cosine problem, for instance, over to a regular cosine problem. All right, that's it for this last video.